me today. So my name is Yanping Jiang. I'm currently a faculty member at Rutgers University. I probably share a little background in terms of how I get into cortisol and also my research interest. My current research primarily focusing on social determinants of health, so I'm very interested in using a biopsychosocial perspective to understand how neighborhood and interpersonal stresses contributes to poor academic health among older adults, particularly old Asian immigrants and older African Americans. I started to analyze and collecting cortisol data was a PhD student back to 2016. So it has been like almost 7 years since I look at the cortisol data, and I had been conducting quite a bit of projects involves using diurnal cortisol. When I preparing today's slides, I was thinking what would be the most I think will be helpful for those who are really interested in studying, like collecting cortisol data and trying to analyze the cortisol data. So I know Dr. Emma Iden already gave a very nice introduction to look at how to prepare the cortisol data and some of the equations and also the analytical plans for looking at diurnal cortisol. So for today's session, I was more thinking about really just provide a hands-on experience. So I'm going to show all the syntax I have and also using an Excel spreadsheet to show how to calculate the time since awakening. That's something that might involve how to prepare the data set before running the analysis in static software. So before I go to my slides, is there any questions for me? Or if you have any questions, feel free to put in the chat. I may not able to monitor that. So if you have any urgent questions that you may need you need pause, just feel free to raise your hand so I can just, go and pause and answer the question if needed. Okay, with that further, I'm just go to talk about the data management and the statistics involves diurnal cortisol. Just give me 1 second. Okay. Can everyone see my slides advance? Oh.
Yep, we can see everything.
Okay.
Everything's
okay, great. Okay, great. Thank you. For today's, I was thinking to cover 2 sections. One section is about some considerations when we collect the cortisol data and how to manage the cortisol data, diurnal cortisol data collected in the lab. And then I will provide some syntax and how to interpret the diurnal cortisol data using M+. Because that's one of the softwares I use, but I also will provide some internal resources if you are not M+ user, like using SPSS or HLM, but I think the basic are kind of similar, and also I would like to give kind of quite a bit time for the Q&A section, just in case you have any questions. This figure probably very familiar to many of you, and I just want to provide here and go quick overview with that, just in case you might miss the formal 2 sessions in terms of diurnal cortisol. So as we all know that diurnal cortisol has a pattern that when individuals wake up, the cortisol levels increase to the peak about 30 minutes after wake up, and the slightly decline over the day. So here, for a lot of researchers who are studying the cortisol, they might be interested in 3 parameters. One parameter is the cortisol level at wake up. And the second parameter is the phenomena that I just mentioned, that the cortisol peak around like 30 minutes after wake up. Here we refer to as cortisol awakening response, or for short we call like CAR, and the diurnal cortisol slope, which capture the changes, the cortisol rate from wake up to the bedtime. So from this figure, we probably know that to capture this diurnal cortisol pattern, that's needed to collecting cortisol samples multi points per day. For example, here has like a wake up time, 30 minutes after wake up time. It could be an additional sample before lunch, or additional sample before dinner, and a sample before bedtime. So just keep this in mind, because for this session, I will primarily focusing on how to model these three parameters using multi-level modeling. So just I think Dr. Adam has mentioned quite a bit in terms of the cortisol data collection. I will just give a little bit quick overview in terms of some considerations that I think is important to think about before to design a study involves the collection of diurnal cortisol. So the first would be really trying to think about like how many, the timing and the frequency of salival samples, like how many days you want to collect your salival samples, and in which day how many samples you would like to collect. But here came with the question, that's why we need to collect in multiple days. As I think many of you probably already know that diurnal cortisol or cortisol itself are very sensitive to internal and external environment. So if we only collecting diurnal cortisol samples across in a single day, it may not really accurately reflects individuals like stable diurnal cortisol patterns, because it can be happens collecting the diurnal cortisol in a day which that person had an exam or had a presentation, which might be very different compared to other times. So which now that's a question, that how many days do you need, or when you design a study that may accurately capture the individual level diurnal cortisol. So here, that's kind of like a debating between, or trade-offs between how accurate, which means how many days you want to collect in the saliva cortisol, and also the potential resource constraints. Like it's well known that cortisol involves data collection and also data assay in the lab, which can be very resource demanding, also involves using funds to support external labs to run all those analysis, specific cortisol assays, and also have to consider the participation burden, because they have to involves multi-time points saliva samples collection for multiple days. So that's no really absolute numbers that you have to collect, like for cortisol, to be able to accurately reflect down cortisol patterns. But I highly recommend these manuscripts talking really provide a nice guideline and description in terms of how we should assess in the saliva cortisol to capture the diurnal cortisol patterns. I think that's kind of a good number to go. It's like a minimum of like 4 days. Sometimes can be something to consider. I also see studies using like collecting cortisol for a week. I haven't really seen like really collecting like more than 2 weeks, but there are some can do that. But as I said, that's a kind of really have to be considered about the participant burden and the resources that you may have to design the study. Another topic I want to mention here is about protocol compliance. After you decide the timeline for the cortisol collection, for example, you might request the participants to collecting the cortisol for 4 times per day, for example, like I wake up or 30 minutes after wake up, and before lunch and before bedtime. So that's a really typical, that's a very critical timeline to assess in the the CRP, which is the cortisol awakening response, because as I said, it really wants to capture that peak value about 30 minutes after the wake up. So it have to be make sure that participants collect the second sample that within time window. So how to assessing that participants compliance with the protocol. So it's very common that studies might be solely rely on self-reports to collect the time when participants collecting the saliva samples. But also, I would like to also introduce something probably you already know, that that's another way to rely on the electronic monitoring devices that, for example, like you can use MEMS cap that can provide a more proximal control of sampling compliances, because those monitor devices can record the exact day and time at which the sampling was open, like the sample tubes you provided for participants when they was opened, and therefore are more likely the time that the sample was taken. However, using the electronic monitoring devices, I'd say, is also kind of resource demanding, because you need to purchase those devices when the resources are constrained. You may need to, you only using those devices for subsamples to really compare the compliances by comparing the data using self-report and the electronic devices to get a sense about the product compliances, because the compliance to the time which cortisol samples was provided, it's very important to accurately capture the cortisol awakening response. Another thing, the last thing I want to mention here is really about the confounders that particularly when you design, because these confounders may decide whether you need to collect this data simultaneously when participants providing the saliva samples, such as wake up time, lifestyles like physical activity, smoking, alcohol use, toothbrushing, or medication use, and sleep quality. Those daily, or we call like momentary level confounders, may have an impact on the cortisol levels. So when you're really thinking about the design of your study, you may need to consider that, is this something you would like to measure during the time when participants collect the saliva samples? But in addition to those considerations, I know there are also multiple factors we need to consider, like saliva sample storage. I know Dr. Moody already gave a very nice seminar last time talking about those, so I will not really go over that section. And I assume that many of you, including myself, may rely on external labs for cortisol assays. So I will also not talk about this today, and then I would like to go direct to the data management. So before we talking about that, I just want to give a quick overview, because I know Dr. Adam already mentioned quite a bit in terms of the data preparation and also the multi-level analysis to capture down cortisol patterns. So for today, I just want to quickly mention that in terms of do the data management, the first thing I always suggest is to do the data quality check. That you probably need to check the cortisol, like whether there are any outliers, how to deal with the outliers, as could be winterized, as suggested by Dr. Adam, or you can consider either excluding those cortisol values which you think could be extremely low or extremely large, that fall out of, could be 3 standard deviations or 4 standard deviations. And here I want to point out one critical thing about time check, because as I said, that's a time protocol in terms of when cortisol will be collected. And this time is very important, because we will use the time to calculate a time variable. Here we call it time since awakening. Sometimes I just call like a WTSA, if that's time since awakening. So here we need the one important thing to get accurate the time variable, so we can accurately calculate that time since awakening to model the down cortisol parameters. And here it's a very kind of unique thing that we using the military time to record the time saliva saliva collection time. And one thing I think also mentioned in the previous seminar is that that's one pitfall when we using the check the data is that if the large sample normally is the sample before the debate time can be collected after midnight, and at that time you may see the time a little off because it could be put like 2 a.m., which is when you calculate the TSA, it might be very, it looks a little off. So you need to check by adding whether there are any samples collected after midnight, and if that's the case, this time may be need to manually record it by adding 24 hours into that before we can calculate the time since awakening. So I'm not gonna go over a lot about data check because I think it's covered by the previous seminar. So I'm gonna go to just a little bit review about the equations that commonly used to model the diurnal cortisol parameters before I go to the Excel sheet to show how to really calculate the time since awakening and how to check the quality of the time variables. So here, I think many of you may be already very familiar with that, oh, sorry about that, cortisol can be, modeled equal to like pi plus pi1 multiplied the time variables time since awakening and time since awakening squared, which this here, the pi2 is really used to capture the curvilinear change as we showed at the beginning that the change from cortisol from the wake up time to the bedtime is not always linear. It's actually a curvilinear change from the wake up to the bedtime. And here, as I said, we are also interested to look at the CAR, that cortisol awakening response. Then here we are coded as like a zero, like for the CAR sample, we code as 1 and other variables coded as 0 to model the cortisol. So here, just keep this. You don't have to memorize this equation. I just want to know here we need a few variables that we might need to manually code it from your data set before we can calculate or we can model the cortisol parameters in statistical software, which including time since awakening, time since awakening squared, and CAR. So before I go to the Excel spreadsheets, is there any questions for what I just talked so far? Nope. Okay, great. Great.
Oops, Doctor, I think we lost your share screen there for a second.
Yes, I'm going to reshare my Excel spreadsheet, but I'm trying to figure out how to close my slides. Just give me 1 second. Let's see.
Gotcha.
Yeah. Okay. Great. Standard deviations it's very common. I list from the publications I have read so far. I think that's quite big studies that using the 3 standard deviations for Windsorization. For my own study, I think the different research may use in different ways, but for my personal perspective, I usually don't Windsorization to treat the outliers. I like to do a sensitivity analysis by dropping the outliers and then kind of redo the analysis and see whether the results has been changed yet. But I won't say that that's any, which way is better than the other way. But back to the question, I would say 3 standard deviation, it's pretty common because it's really kind of just, be a very small percentage of the cortisol samples will be Windsorized. based on that criterion.
Thank you so much for answering that. And do you, I know one common question that we tend to get is whether or not you log transform your data before you do your analysis, or if that's a question that's coming up, I can be quiet.
Yes, so I didn't touch base that because I know it was covered before. I would say for cortisol data, at least most of the cortisol data I had been working so far, I always can see a non-normal distribution because it's just really that more, I would say, I think it's more like a positive skewed or I cannot recall exactly, but it's normally not normally distributed. So, but when we do the like multi-level model, it's always more like regressions. Basically, it's regression analysis, right? And that's assumptions that we made in terms of regression analysis that we assume the dependent variable is normally distributed. However, the raw cortisol data many times are not. So I personally also see other studies do that. The log transformation is very common. My personal preference to log transform the cortisol data. And before I do log transformation, I will add a constant 1 into the cortisol data just to avoid inactive values because it's just hard to interpret inactive values. But anyway, regardless how you do the log transformation, it should not change the significance of results, but may change some of the interpretation, particularly the like your intercept, right? Because you already changed the unit of the cortisol data. Does that make sense?
It does. Thank you so much for that.
Okay, great. So I am gonna transfer to the to talk about some expressions. I don't know whether, because when I prepare the slides, I'm not sure whether you have any experience working from the raw data. But I think for me, like when I studied looking at the cortisol data, I found it's very helpful to really know how to, like when I had the raw data, I'm gonna compute the TSA, how I'm gonna check the data, because particularly you have large samples. Sometimes we enter the like test data, you might get some errors like how to check the data. So I personally have, it's more just from my personal experience. It's not really presents like a standard to do things or anything. So I just want to share like some like practices I am currently doing to calculate the cortisol, like diurnal cortisol data and to help me run the analysis. So it's not really like, I would say it's not really like a protocol something, so, but I just want to share. I hope this can be helpful. So this data is actually publicly available from the minus data set. I don't using all the data sets, but I just want to quickly go overview a few variables here, and then I will go over to just introduce you how to calculate all those variables, including how to impute the missing data in the time variables, because at least from my personal experience, it's very common that participants may miss one of the cortisol samples. They do not provide any time variables. So, and particularly when the sample size is not like really big, you want to keep the data, right? So how are we gonna impute the TSA data and how to make sure that the imputed TSA data makes sense? So to go over from here, I want to make sure that for the cortisol, this is cortisol time. But interesting part is that here we don't see it's really showing the military time because it's already been coded. It's just very easy to code it this time. You can either like use the Excel spreadsheet or SPSS. It's just very, very easy to kind of convert the time variable to numeric variable. And here I already just do that just to save some time. And this is the cortisol data in this X column. I know, and here because the minus data, the cortisol was I set in singlets, so that's only one cortisol value. If you want to do the duplicates, which means you have the kind of kind of split the cortisol samples into like halves and redo analysis. And that in that case, you probably want to average the cortisol values from two assets and creates a more sometimes we call them maybe more reliable, because only conducting cortisol assay once may have some, noises, and you may not able to know that. And here I want to say this is very particular in terms of this is the number of the order of cortisol samples for each day. So here's 1, 2, 3, 4, and here it's the number of the day when cortisol is collected. These two are all you can enter the data or manually coded. And here I cannot recall whether I'm manually coded from minus already provide this data. But I want to point out that using this spreadsheet or the kind of equations I will provide, it's very important.
What?
If you could please make sure you're muted, that would be great.
Okay. So when looking at this two variable, it's very, very important to rank the numbers. Here I have to rank from like order of the day from 1, 2, 3, 4. And here for the column Y, for the order of the cortisol sample for each day, it's very important to rank from 1, 2, 3, 4. The first cortisol sample, which is here, it's the sample collected at wake up, and the second sample is the sample collected 30 minutes after wake up, and the third sample is the cortisol sample collected before lunch, and the fourth sample is the cortisol sample collected before bed, if my memory is correct. But it's very important to rank the numbers, because you will see when I calculate, it's important to rely on these variables. And when you do that, and make sure that you rank all the variables by using this order. You can either using Excel to do the order, to rank the order. You can using the SPSS file if you are using SPSS. We won't skip this variable, and here I already recorded. It's really, as I said, when we go back to the equation, that is a variable called the CAR, which is actually manually coded when you collect all the data. So how to manually code the CAR sample? It's very easy. Basically, you just need to code. You can create a dummy variable, which is very common, which is you using the second, you code the second sample as 1 and the rest of samples as 0, and you included the CR as a variable in the equation to be able to model the kind of the size of the CAR in the model. So now let's move to really see how to calculate the TSA. So bear me, because I'm not really good at Excel spreadsheets. I only using that for calculating all those TSA's variables. So I'm gonna just like I already calculated this variable by myself, just in case if I forgot today. But I will go over to just calculate all the variables one more time to just show how to do that. So here, let's say this is TSA. If we are interested, so we're gonna calculate the TSA, which is time since awakening. And here, that's a tricky part. No, sorry. And for the TSA, that's kind of very common practice. I won't say it's standard practice, but a common practice to code the first sample, the time for the first sample as 0, and then you calculate the time, which could be like in hours, which is probably a reasonable unit, because if you calculate it like in minutes, it could be very, very large. So you can calculate the time differences from the second sample to the first sample, and then the third sample to the first sample, and the fourth sample to the first sample. in hours. So you calculate the differences we call time since awakening. The way that called the first sample, the time for the first sample equals to 0, that basically you can trade the intercept from the model, kind of an estimation for the cortisol at awakening, because you coded the time since awakening for the first sample equals to 0. So let's go ahead to do how to calculate TSA. Remember, we have to, rank the day of the cortisol and also the order of the samples using this way. We're gonna study from, let's study from this here, this sample, the first sample here. We're gonna do equals if so when if it's cortisol sample, sorry, it's from the last sample. So we can calculate when cortisol sample here equals to 0, 1. We will code the TSA as 0. However, and then if cortisol sample equals 2, then the TSA would be the cortisol time minus the column above. And if cost sample equals 3, then it will be the call time minus to the second 1, 2. So 2 columns above. And because the last one is, that's only one option, we don't have to add if. Sorry. Last one would be last column equals to the first column. Okay, let's see what's going on here. Sorry about that. So let's see whether we calculate this correctly. I think we did. So just want to show you that we already calculated the TSA. You can see the minus have left missing data for the time variables. So after we calculate the TSA, so we can just go double check, see whether this is accurately calculated. So for the first sample, TSA is 0, and for the second sample, we can see the time difference from the second sample to the first sample is 8.17 minus 6.50. I think it's 1.667, so it's correct. See, and the third sample it's collected 12.50, which actually is like 12.30 minus the 6.50, so it's 6. So it's 6 correct. So we can double check that the TSA is correct. So after we calculate the TSA, normally I will do a TSA check, which means because we assume that the cortisol data, the cortisol samples are collected in order, right? Which means that that's logical that the time, the TSA as the fourth sample will be larger than the third sample, and the same third sample, the time for the third sample will larger for the second sample, which means I need to check whether if I'm using a later cortisol sample time to minus the previous cortisol sample, the TSA should give me a positive value. That's kind of a way for me to check whether something off, or I have to go back check to the time variable. So I'm gonna also show how to do that. Collecting called TSA check. So for the TSA check, I also using the function. So I'm if sorry, from here, sorry. Let's see how to do that. If the cortisol sample equals 0, so equals 1, it's 0 because it's the first sample, so TSA will be 0. And if cortisol sample, the order of cortisol sample larger than 1, I'm gonna using the TSA minus TS, the one before that to check the variables. So this I'm trying to check whether the later sample, the TSA time for the later sample, it's larger than the previous sample, which makes sense because cortisol is supposed to be collected in an order that the time is supposed to be larger because we're using the 12-hour meter time, so we can check. See, we got some negative values. We want to see what's going on. So here, I'm not gonna really try to debug the data, but I just want to show when you find some negative values, it's always good to go back and check whether there's something wrong here. For example, you can see very quick thing like here, let's see, this here, the cortisol is the 4, like order of the cortisol sample is 4, which means the last sample, but look at the data, look at the cortisol time here is like 5. Is that 5 p.m. or 5 a.m.? Probably don't know. So, and we can see that the TSA is a little bit off, which means the equations or the Excel function we use for calculate TSA may not work for this specific TSA row. So we probably need to go back to check whether there's anything wrong with the cortisol time or the function here maybe not work because, as I said, we are trying to use in 24-hour meter time, but there are some participants may collect the data at midnight, after midnight. Also, there are participants who actually do a night shift that their wake time probably would be the evening time. And using the weights that we just used may not really accurate collecting the TSA. So I always look using this way to do a TSA check to see whether there are negative values and to see whether it's because of the function I use may not apply in this situation, or see whether the cortisol time is accurate or not. So I'm not gonna really do that, but I will just say this is one way you can check your cortisol data. Sorry. So after you check all those TSA, and I would like to collect, let's see, remove all those, like we can see the non-variables here because we want to do imputation. So before I move to the TSA imputations, any questions about how to calculate the TSA? Okay, great. Let's see.
Doctor, we did have a question in the chat about CAR. Tico wanted to know, she had a question about clarification of the cortisol awakening response, but I wasn't sure if you were going to talk about that a little bit more later.
Probably not, if not related to the statistical analysis.
Okay. Well, the question was, is the well, and hopefully, and Tico, let me know if I answered your question. But the question is, they just said that they were a bit confused about the cortisol ranking response. And what I told her, and correct me if I'm wrong, doctor, is that it is a dummy variable. And a dummy variable, for those who don't know, means that it's recorded as 0 or 1. And 1 indicates which time point that the cortisol awakening response is going to refer to. And that time point is 30 minutes after waking. So if it's marked as 0, all it's saying is that this is not the cortisol awakening time point. And if it's marked at 1, it's just indicating that this is the saliva sample that was taken 30 minutes after waking. Correct, doctor?
So I think it's pretty accurate, but that's one thing that, so here we have like, for while coding the CAR or cortisol awakening response, I haven't really considered about the compliance, but I will talk about like when cortisol sample supposed to provide at that 30-minute time frame, but what's not, like participant not really complying with the protocol, how we treat that, right? So have to check whether the CR was compliant or not, like whether that's a, have to like, for me, like I will create a additional variable to indicate whether the second sample follows the protocol or not. We call like compliance, CR compliance issue. But back to the question in terms of the how to code like this dummy variable. So just for those who don't know dummy variable is like a coding using 1 or 0 to coding, could be like a yes or no question. So you're coding like only 2 values. And for here, as you know, Shannon just explained that we do not really consider in terms of the actual time the cortisol is collected to code the CR. Instead, we just, regardless the second sample that participant provided, which if your protocol, the second sample supposed to be collected after like 30 minutes after wake up. If this is your second sample, then and then code this second sample using like code as 1, and the rest of the samples like collecting at wake up or before lunch or before bedtime, if this is your time frame when collecting saliva cortisol, then the rest of the samples then we code as 0. Does that make sense here?
Hi, yeah, that does make sense. Thank you. I guess I was also wondering like what happens if you're missing data. So if anyone's missing on 1 or 2, how that then
Yes.
lines up for the remaining measurements.
Yeah, that's a great question. So for here, for the CAR, I normally, whether participant provide data or not, I will still code as 1 if this is supposed to be the CAR sample or the sample that collected 30 minutes after wake up. I think you also raised a very good question that I was not mentioned at the beginning, that when prepare the Excel spreadsheet, my rule is that I normally do not like, even the participant do not provide any cortisol data, I still will have a line here to just indicate as all the missing data, which make sure that I have exactly the same row. For example, if I collecting 4 cortisol samples for 4 days, which I will have 16 samples. 16 samples. So for the data entry purpose, I will make sure each participant in the study have 16 rows, which this is like in a in the long format, which means each cortisol sample will have 1 row indicating its information. And also other additional information you would like to collect during the cortisol sampling period. Which means even one participant do not provide any cortisol data from the data entry purpose, I'll still recommend to keep all those 16 rows in the Excel spreadsheet for a few for later on missing data analysis. With that said, that in terms of the CAR coding, I was to do the same thing. That as far as I know, even participants do not provide the first sample and the second sample, I was to code the second sample as 1 and the other sample is 0, even there is no cortisol data there. Because when we go to the data analysis, particularly using like Unplus, that the missing data on the outcome variable, that any single role in this analysis, if that's missing data in the cortisol, that row actually will be deleted from data analysis. But I still will code the CAR here just for the data analysis purpose. Okay, any additional questions before I move on? Okay, great. So after I check the TSA now, I see if you're writing, for example, if in your study that's no any missing data, actually here it's almost done, that you don't have to do any additional work because you already calculated the TSA. You can do like TSA square by multiply TSA and TSA to calculate that, but I just want to read, like in real data, sometimes it's not really as we thought. We hope there's no missing data. Actually, probably not that way. So for my own study, I like to impute the TSA, just make sure that I can keep all the cortisol data. I generally do not impute any cortisol data because for the using the Unplus analysis, Unplus software, that any missing data in the outcomes will be dealt with using the FEMO. So here I like to impute the TSA, just trying to keep the sample size. But I would like to say that there is no this is not standard that you have to impute the TSA, but I just want to provide the Excel function if you are interested to impute the TSA, to just make sure you wanted to keep all the all the data in your analysis, or you don't want to losing any data just because participants do not provide the time variable. But as I said, you also have to check the portion of the time variable that it's missing, because as I said, that time variable is very important to model the diurnal cortisol slope, because it's basically a function of the time. So getting the accuracy of the TSA is important, but with there's a lot of missing data, it's maybe not likely that the TSA can be balanced because of the imputation process. But I still want to just provide the way that how to calculate how to do the imputation using the Excel spreadsheet. So I would like to go here. I'm gonna copy the data and I'm gonna to just paste with all the values, because that's gonna remove all the function implied, just in case that if there are any changes that won't affect here. And I remove all the non-variables just in case, just remove all the errors here to provide an error-free TSA. With the content. So I also would like go back to the TSA imputation introduced by Dr. Emma, because for my personal experience, I kind of also follow the same rule, that I like to using personal TSA mean values to impute the TSA first, because it's more close to someone's actual TSA time, and only if when the TSA and the personal mean value is not available, I probably using the TSA values for the whole sample to do the imputation to increase the accuracy. Okay. Let's say error. So I would like to go over to create the mean, the personal mean for the TSA for each participant, and then we can do the imputation. Let's starting from the second participant, so we would have enough room to do the calculation. Let's see, it's from here. So you don't have to memorize the all those functions, because if you like, I can share the this Excel spreadsheet which had all the functions here. Let's see if so we now have to use in the order of the day, when here the day equals 0. We need, because when we calculate TSA, we have to calculate TSA mean by each sample instead of calculate the whole, because it doesn't make sense. We need to do the average of the, let's see, first. So if this is the first day, then we need to do here, 4 down here, and 4 down here, and 4 down here. Because it's at 4 days, so we need to do 4 days of the TSA for the first sample. And if cortisol day equals 2, the second day, and average 1, the second day, and then we also go back to the 4 columns up. And if equals to the third day, here it's the cortisol was collected for 4 days. So if the day of cortisol equals the third day, the average first and 4 columns up, another 4 columns up. And for the last, it's the 4th day. We don't have to give any if, because that's the only thing. So we're gonna go, sorry. Oh, oops, what did I do? Sorry, go back here. Average, the last day, the 4th day, we have to go this. The 4th day, we do all the, go back to the 4 column. Okay. So you can see this is the imputed, the TSA personal mean for each participant. And let's see. I am gonna to copy and paste. Also remove all the errors here. So after the after calculating the TSA at a personal mean for each participant, normally I will check whether this would be able to really help impute all the TSA values. If not, I will go ahead to see whether there's a need to impute with the grand mean, which is the mean of the TSA for each sample for the whole for the first sample. I think this is more like a decision based on your actual data you have. So today I will just go all the possible solutions that you may need to really get a fair data set that with no missing data in the TSA. So I'm going to go back direct to here because I don't want to save some time. I already calculated the grand mean for each sample. This is calculated using the first sample, which here has like about more than 2,000 samples to calculate the TSA the grand mean for TSA at the first sample, second sample, the third sample, and the fourth sample. So after calculating the TSA personal mean and the grand mean, I normally like to create a TSA computing means to prepare for the imputation. So here I will skip to just demo to show how to do that. I will just go over to give you the function. We can go from here. So you can see it's really just go back to see whether if TSA personal mean is, let me see it here. If this is blank, then we will impute when the order of the sample equals 1, it's 0. So in place with 0, because we all know that the first sample TSA is 0. And for the second sample, we will impute exactly value from this second row, which is the AN, the column AN in second row. And we will also, when the sample, if the order of sample is equals 3, which the third sample will including this value, the same for the fourth value. So we will create a TSA computed mean. In this column, you're supposed to get all the variables you have, which means there's no missing data here, because if there's any missing data, which means there's no personal mean TSA available, it all will be replaced with the grand mean. So now this is something I would say kind of important, or something you might be interested, that after calculating all the TSA mean, how we gonna impute the TSA mean, right? Because you want to keep the original TSA values calculated using the actual time. And when there's missing data, I would like to replace with the computed means using the either personal mean or the grand mean that calculate in this column. So it's also very simple using the function that you can use, say, when here the TSA, when this AE column with TSA error removed. So when this column is blank, we can use in this comma here, then replace with values in this column. If not, we go back, if there's no missing data, we just copy the values from the TSA calculated using the time variable. So we will get this new column, which means with imputed TSA value, and that's no missing data for this column. We can see here. So this kind of the whole process in terms of how to calculate and impute TSA. But as I said, whether there's a need to impute TSA, it's really depending on the missing portion in your data and whether you have any concerns that this imputation may bias the TSA values. That's not really like, I have not came across any paper talking about like what would be a rules of thumb to do, like whether you should go ahead to the TSA, but this is more from my personal experience that if I didn't see a large missing data in the time variables, I normally will go ahead to do the TSA imputation, and I would like to first impute with the personal mean, and when personal mean is not available, I would like to impute with the grand mean if this is necessary. But I would be very cautious when I impute using the grand mean, because if that participant don't provide any time variables, I probably just treat it as missing data, because it's probably not really, the grand mean probably will not provide any information for that. So after checking the TSA, the imputed TSA, I will go back again to do the TSA check as the equations I provided to look at whether like the TSA value for the fourth sample is larger than the third sample. If not, then something could be off, right? You probably need to check whether this makes sense to impute this variable. If not, should I just treat it as missing data? I would always suggest to go back check one more time, because you would not want to end up that having a TSA for the fourth sample, which is smaller than the TSA for the third sample, because that's supposed not right. And also very easy to do the TSA square. You just need to multiply you can multiply the AQ with AQ column. The last thing, go back to the question that relevant to the CAR samples, that I like to kind of code another dummy variable indicating the CAR compliance. There are quite a bit ways to do how to do the CAR compliance, and also some of the cutoff values, like which time window that should consider as not CAR compliance. I know there are some studies that suggest a little bit more strict rule using like 10 minutes window, which means that cortisol samples collected 20 minutes after wake up, and within like 20 to 40 minutes after wake up, consider as CAR compliance, even if it's not exactly the 30 minutes after wake up. This kind of 10 minutes kind of wiggle room to still consider as CAR compliance. I also see some studies using 15 minutes. I'm not sure that any rules has been agreed upon in terms of how many minutes should be considered as the range that should consider as CAR compliance. I'm personally using 10 minutes, that CAR samples collected within 10 minutes of the predetermined protocol considered as CAR compliance. So which means that the second sample or CAR sample collected less than 40 minutes after wake up, or after 40 minutes after wake up should be coded as CAR non-compliance in this variable. So I also provide a function to how to code the CAR compliance. It's very simple. I'm gonna show here. So basically we can use an if function that ends when we can go back to here, that when that's the reason I called the CAR sample here. So when the CAR equals 1, which means indicating this is a CAR sample, that when the TSA minus to smaller than 0.33 or larger than 0.67, which means like less than 20 minutes or longer than 40 minutes, it return to 1 value here, otherwise return to 0, which means for this dummy variable I created, that 1 refers to the non-compliant CR samples, and 0 indicates either could be non-CR samples or CR samples that are compliant with the protocol. And there are quite a bit ways how to model or how to treat the CAR compliant, non-CAR compliance variables in the analysis. I personally don't have any preference, but I would like to provide some of the common approaches has been used in previous studies. One approach that I see from previous publications is to just drop the non-compliant CR samples from analysis, which means go back to treat the manually code the cortisol samples as missing data if this is coded as the CR non-compliance sample. Another way that I recently been suggested by one of the paper we submitted from the reviewer is that to treat those non-CR compliant samples as non-CR samples, which means, for example, for this CR sample, it's non-compliance because when we go back, we can see the TS time is 1.67, which means it's collected after like 1 hour after wake up. So for this, you can either just treat the cortisol sample collect at this as missing data, or you can go back to change the CR to as 0, which means you treat this as a non-CR sample. Okay, this is kind of pretty much what I have for the how to calculate the TSA and to prepare all the parameters before we go to run the analysis in Plus. So I'm also gonna to stop. I'm gonna stop sharing and see whether we have any questions. And after, I think probably we can take maybe 10 minutes or 5 minutes break before I go back to talk about the data analysis in Plus and how to interpret the results from the M+. Let's see how to.
Okay, does anyone have any questions at all? If so, feel free to put them in to chat or unmute yourself and ask away. Okay, if there are no questions, let's go ahead. Do you want to do, Doctor, would you like to do a 10 or 15-minute break?
Let me see. How about we do like a 10 minutes break? I just want to make sure that we have some time for Q&A session, if that works.
Yep. Let's go ahead and take a 10-minute break, everyone, and then come on back. Again, if you think of any questions during that time, feel free to put them into the chat. And thank you again, Doctor, for agreeing to share that spreadsheet with us. That's excellent. And for folks who aren't familiar with the MIDAS data set, I'll pop a link into the chat for that in case you're wondering what data set this is coming from.
Yeah. Thank you so much for that.
No problem. All right, folks, see you back at 1:25 CST, and I think that's 2:25 Eastern.
Let's see. Could you see my screen?
We can. Yep.
Great. So I just presented how to using the Excel sheet to calculate the TSA. Also back to like since the previous seminar has discussed the way how to deal with like non-normally distributed cortisol data and the outliers. So we're not talking more about how to manipulate the cortisol data. And then I will just jump to talking about the data analysis, assuming that all the data are ready to go and we already checked the data accuracy. I would assume some of you may already had experience to analyzing the cortisol data using multi-level modeling, but if not, I think today I will just go more. Don't be scared with all the equations that I will present. And you don't have to memorize the equations. I just want to present some of them just to help facilitate understanding of the multi-level modeling. But for today's seminar, we're more trying to focusing on how to using plus to run analysis and how to interpret the findings from the plus output. Before we thinking about like analyzing the diurnal cortisol data, we already know that we may need to collect multiple cortisol samples in a single day for multiple days for one participant. So when I describe that, you will know that's a nesting data structure because the cortisol data was within the day level because like we have multiple days. So cortisol data and we have the daily level data and individual level data. So here we have kind of 3 level of the data structure that is individual variables, daily level variables, and cortisol variables, right? So when we consider the data analysis, we probably need to consider to adjust this multi-level structure of the data in the cortisol, diurnal cortisol data collected. So the point to come to here is that should I use a 3-level modeling or 2-level multi-level modeling? I was asking is that, yes, it's pretty straightforward to say I'm going to go directly using 3-level modeling, but I would like to provide, it's basically like the kind of more accurate standard way to do that, but I'm not saying that I'm opposing using 3-level modeling, but there are just a few considerations because I want to mention that conducting 3-level modeling with random intercept and random slope EM plus, it's kind of time consuming. I could not remember, but I did one. I feel like when the sample size is large, for example, like you have 1,000 participants, it could take a few minutes to run a 3-level multi-level modeling in M plus. And for 2-level modeling, which probably you will be to kind of average the daily level variables into the personal level and to kind of really don't trying to deal with the day level variations. And in that case, it will be much faster to run the analysis. But with that said, I just want to say, in my previous studies, that sometimes I also using 2-level modeling to understand to model the diurnal cortisol patterns if the daily level variations is not the focus of study, or I'm not interested in understanding the day level variations in diurnal cortisol, then I probably will go to 2-level modeling. But as I said, 3-level modeling is kind of the best or the most fit models to run that because of the 3-level structure of the diurnal cortisol data. And another kind of thing to think about when do the data analysis, as I just touched base a little bit, is about how to treat non-compliant CR samples. As I said, there could be 2 approaches: could treat as missing or recorded as non-CR samples. And another, I see that another but that's a third option is to create that non-compliance dummy variable and do not like treat it as missing or just treat it as non-CR samples. Instead, trying to including that non-compliance dummy variable as a covariate in analysis. By doing that, trying to account for the potential impact of the non-compliant CR samples in the analysis. Another thing, a third items I want to mention here is that whether you would consider doing some sensitivity analysis. I see that it's pretty common in the cortisol analysis. In my own studies, I also like to conduct some sensitivity analysis, just in case that in the situations that some samples might have impact on the findings, but I don't want to drop them because the sample size is small. So I want to conduct some sensitivity analysis just to see whether dropping those analysis or treating them as missing data might impact the findings For example, you might including participants who work night shifts, right? So you will see their diurnal cortisol pattern might be different from the rest of the participants recruited in your study. So in that case, you might need to consider, should I do some sensitivity analysis to drop that participants and see whether the findings are remain significant to just increase the robustness of the findings. So that's kind of something that I would suggest to consider before to design the data analysis, like kind of conduct your data analysis. Okay, I'm gonna give an example, specific example from my own study that using 3-level multi-leveling to run the diurnal cortisol data in M+. So here is kind of equations. Don't be scared about that. It's not like it's kind of technical, but I want to kind of break down and go over with that. So I'm writing here in like level 1, level 2, level 3, because this is how M+ handle multi-level modeling. I really recommend this software to do multi-level modeling because it's just very straightforward and you can exactly know that which like parameters indicates which which effects that it's easy to interpret, more straightforward. Sometimes I consider it's more straightforward than mixed effects, but I also will provide that as alternative plans. So for here, the level 1 we call could be the cortisol level, that we were modeling all the cortisol samples. That here the CAR is included the pi 1ij. It's actually in terms of the impact of it's the impact of the CAR on the cortisol, and the coefficient for the pi 1ij, well, something you will be interested if you are interested in the strength of the CAR. And the time since awakening will be a very important parameters if you are interested in looking at the diurnal cortisol slope. And this is referred to the pi 2ij. And we also included the time since awakening square in the analysis. And here you can see the pi 3ij does not include in the level 2 and level 3 because we treated it as a fixed effect in the model, even though that's a curvilinear effect of the cortisol change during the day, but because this study are not interesting to understand whether any factors may have impact on this curvilinear change. So that's no predictors to predict this change. So I treat it as a fixed effect in this model, and then you can add any cortisol level variables. For example, if you collected whether participant conduct any physical activity during that specific cortisol sample, it's provided, right? You can add all those covariates in this model, and we see all the effects here as like a momentary effect. And now go to the level 2, which is the day level. Here you can see that all the pi 0ij, which actually interpret as the cortisol awakening, because we treat the TSA for the first sample equals to 0. So here's a random intercept, and you can add all those day level variables. Could be wake up time for that day when cortisol is provided. You also can add other day level variables that you think could have impact on cortisol. For example, whether the day is a weekend or it's a weekday, could have an impact because of work stress. And here you can see the pi ij and the pi 2ij is basically the random slope for the cortisol awakening response and the diurnal cortisol slope. Similar here, the level 3 is to treat all those at the random intercept and the random slope and adding the personal level variables. So this kind of equation that I found writing in the multi-level way. It's easy to understand and pretty straightforward. You basically add personal level variables in level 3, which is the personal level, and day level variables at the level 2, which is day level. And here it's more like an equation written for M+, but for those who don't use M+, you might can use SPSS, SAS, Strata, or R to run the multi-level modeling. In that case, those models commonly, maybe more commonly known as mixed effects model. So it's the same, but instead of writing the equations in multiple levels, it's actually substituting the equations at levels 2 and level 3 into level 1, become a very long equation. So just in case some of you might know this variable as mixed effects, but basically they are kind of, I won't say that the same model, but it's just different terminology in different fields. So I'm going to go to execute this equation in M+, and I provide the syntax here. I'm not sure how many of you using M+, but if for those who are not familiar with M+, it's a software that designed kind of very user-friendly to model latent variables, and I thought it's very helpful to run the multi-level modeling. The syntax is pretty readable, and it's more like writing, I would say, in the words that we understand instead of like more like other programming language that sometimes have more steep learning curve. So for here, the words that are highlighted in bold, it's like more like a function. Let's go over. So for the M+, we first need to prepare a data set. This is a little bit a tricky part, but I just want, for those who are not familiar with M+, you can save the DAT file using SPSS. The only thing that have to be reminded when save the files that do not save the name variables, because M+ cannot read the variable name. So that's the reason that we have a specific variable section here to just, you can now rename all the variables that you have. So just when you save the variables, just make sure that you know which variable, like which row represents which variable, because you basically have to write them down. They won't provide that. So here I have pretty simple. I just want to go over that the ID is the participant ID, and the end day is end day is the day ID for each specific participant. I want to mention that this NID is slightly different from the day of the, or that the order of the day that we I coded in the Excel spreadsheet, like 1 1 2 2 2 3 3 4 4 no. So here the end day is a specific day ID for each participant, which means it has to be unique. You can create by yourself, but it's basically just like using a unique ID to represent the day for each specific participant. And here the cortisol is the cortisol value. And here I also have adherence, and the CAR is the dummy coded CAR variable. And the TSA is time since awakening, and the TSA score is time since awakening score. So here this function is to give the name for the variables, and the user variables is like the variables I want to using from this data, because you can have more variables that saved in this data set. But if you are not going to use all the variables, instead you want to use in specific variables. So here you have to specify which variables you would like to use by assign like user variables equals to ID and day, cortisol, CR, TSA score. So here it's really trying to identify the cluster, right? Which like how the data structure look like. So here that's two cluster ID, which is the participant ID, which is the personal level, it's the ID, and the end day, it's the day level ID that cluster them, because the cortisol is classed as the NID and the NID classed as the participants. And here, have to specify, which means to tell N plus which variables is the level 1 variables and which are the between variables. Here, between variables are ID and the day level and the participant level. So here, because we don't have any predictors, we do not be defined, but if you want, is you just put between equals blah, blah, blah. And here we're using within equals CR, TSA score, because those are cortisol level variables. And here it's really trying to define the missing data. If you have any missing data, then here we have negative 999 as the value to represent missing data. So you can specify you have using a specific value to represent the missing data. So after specify the data source, the variables, that you go to analysis. And here, as I said, we're gonna also look at the 3-level random missing, which means we have missing data, and this is a random intercept and random slope model, and it's a 3-level multi-level modeling. And for the estimator, we're using the maximum likelihood with robust error. I like to use in this one because it can provide a little more robust estimation even when the distribution of the variables are not perfectly normally distributed. And here it's really trying to tell N plus which models you would like to look at, like how the models look like. So basically we're gonna execute the equations we had at the previous slides. We have to tell N plus, this is the within equation. So we put this like 100% and within like have this percent here. And in the N plus, the on, it tells you we're gonna do a regression analysis, and the slash by adding this called this is the random slope. So here cortisol on TSA, which we use to estimate the cortisol diurnal cortisol slope, and we treat diurnal cortisol slope as a random slope in the analysis because we allow them to vary across the day level and vary across the individual level, which makes sense because we assume that the diurnal cortisol can change across in days, right? In some days, the cortisol can be different. As I said, the diurnal cortisol are very sensitive to external environment, and there are also variations between participants. So we treat them to be very estimated across in the day and across in the participants. And similar here, the S1 I actually used to do the random slope for the CR, which also allowed this parameter to be random estimated across in the day and across the ID. And here you can see I treated the curvilinear effect with the TSA score as a fixed effect. So I do not generate a random slope from here. So you can see that's no any like slash or slope from here. Basically, this is a fixed effect. And between days, so we actually basically tell N plus that we're gonna run the second level, which is the day level. We would allow the intercept, which is the cortisol itself, right? The cortisol variable, and this will use to estimate the cortisol awakening between across the days within one participant. So we allow them to randomly estimate it. At the same time, I also like interested whether there will be any, correlations between the cortisol awakening and the slope, and also the slope with the CR. And just in case, even they are three independent parameters, but one parameter can have impact on the second parameter. So sometimes I will include this as here to just account for their potential correlations among the parameters. And the same here for the between ID, which is the personal level 3. I also allow the intercept, which is cortisol with 3, and the random slope for the cortisol slope and CR to randomly estimate it across the individual participants. So this is basically the slides. And for some of you, if you are interested in, for example, you probably like, I don't really want to run all my analysis in plots, or I'm interested I want to extract down the cortisol slope to do some additional analysis. For example, you are interested to testing whether down the slope could be a mediator linking, for example, early childhood abuse to like physical health outcomes. You want treating down cortisol as a mediator. Maybe in this situation that you may not feel comfortable to run the mediation analysis using like multi-level modeling, you wanted to, extracting the accurate down cortisol slopes and to do additional analysis, you can using the save data function. This is very simple. You can save file as this a name, you can have a name on it and to save the F factor scores. And this will provide you all the estimated cortisol awakening, CAR and TSA, which is and TSA, which is diurnal cortisol slope, and also will provide you stand errors that for each day level and the participant level, if you are interested in by only extracting the data from this analysis and wants to do some additional analysis using either different softwares or the same plus, but you want using a different model, you can just save the all those parameters using this function. I'm going to go back to look at the results. So once you run the analysis, use M+, it will give you some outputs. Now I'm going to let's just go quickly over in terms of the data. As this is more like we call unconditional multi-level modeling, which means there's no any predicts included in this model. So within level, which is, as I said, it's a curvilinear trend, we can see the estimates is 0.02, and this is significant, which means we can see a significant curvilinear trend for the cortisol. And here we also can see all those correlations between the parameters across in the day level, which is like a more within person between day effect. And here we can see the correlation relationships are statistically significant. We also see the variations. The variations are also significant, which means that we can see the diurnal cortisol parameters fluctuate across in days within the same participant. Because here is we talking about variations in cortisol awakening slope, diurnal cortisol slope, and CAR within one person. And here, this is like a between ID level, which is personal level. As we can see that here, since the cortisol awakening and down cortisol slope are significantly correlated, but not others, we can see here from here. Here it's more like a between participant or crossing participant level effect instead of more talking about within level. Within participant effects that talked in the between and day level. So here we also can tell, okay, this is like actual data we had in another project, in one of my previous projects. And I want to point out that here we didn't find a significant CAR because of the non-compliances, but usually that when you check the mean variables, you can see that there's a significant CAR here that, as I said, as we introduced early, that there's a peak in cortisol value about 30 minutes after wake up. But here, unfortunately, for some reason, we did not detect a significant. And here, the mean, it's really about the average cortisol pattern. You can really look at those parameters and see how the cortisol changes across in the whole sample, right? And but remember, as I said, this data has been, the cortisol values has been log transformed. So these are not like absolutely raw cortisol values. Instead, they're more the unit has been adjusted. But you can see that cortisol awakening are positive and also significant, and that's a relative decline across the day as it's down across the slope, which is significant. But as I said, the CAI is not significant, even they have a positive value, because we can see a increase in cortisol values from the cortisol awakening to the second sample. And here also very interesting is to look at the variations between person, particularly when you design a study, you probably might interesting what other personal level factors, right, might be predict the differences in the cortisol parameters across in participants. And here you can see all the three parameters, cortisol awakening, CAI and cortisol slopes are significantly, the variance are statistically significant, which means we can see the variations between participants. So now I want to move to like, what if I'm also interested in adding predictors in this unconditional model to test any significant personal level or daily level factors might impact on the cortisol parameters. I give an example about like age, which I had all the syntax that are added in the formal slides in red. So all those syntax in red is the additional syntax added to model age as a predictor in this analysis. So here we go. Like first, when you had age, you have to add age in the variable list if you already have that. Sorry, that's a mistake here. You also need to add the age in the user variables. So you tell the and plus that age now is a user variables in this model. And that's the part that I want to highlight here is that because age is a between person level variable, you have to let them plus know to tell them, hey, between equals to, because we have two levels, which is ID level and NDI level. So you have to tell this is the ID level variable. So you have to like ID age. I also give an additional example that when you have both both predictors, one at the personal level, another at the day level, such as wake up time, you can tell them between equals ID parenthesis age, tell them that age is the ID level, which is participant level, predictors and end day level is like a day level predictor for wake up time. To tell the plus that how they should treat each variables in each level. And the same, but one thing add here is like something have to consider is the century, like whether you need to century the variables. I have one additional slides after this slides to talk about a little more about centering, because I think it's something also important in terms of running multi-level modeling, because centering can impact how to interpret the intercept. And also if I'm interested to distinguish the between person level effect and the within person effect, that centering plays a important role in this process. So I'm gonna go back, circulate this back later. And here, the same model, the same, instead of you need to add that that age, treat age as a predictor, at the between ID level to add the syntax to tell plus, I am including the age as a predictor for the cortisol slope, CAR, and cortisol awakening. So now this is the results, because the age is included as a individual personal level factor. So we will just go back to look at these results and between level ID, and we can see that age on cortisol, down cortisol slope is not significant, but that's a significant impact on the CLR, but not the cortisol awakening. So basically, you can tell this is the estimates, and this is the significance. One thing I want to point out is to interpret the estimates to see whether that is whether like this impact has a more like a steeper impact, like a steeper cortisol slope, or has a more blunted slope. I wanted to point out a little bit because the diurnal cortisol slope in most studies, if like just based on the nature of the diurnal cortisol pattern, that the cortisol slope is generally or commonly is a negative value, which means when the estimates here, when the estimates is positive, which means that this predictor may be associated with a more blunted diurnal cortisol slope. And when the estimates is negative, which means that predictor may be associated with a more steeper diurnal cortisol change. Just provide a little bit interpretation, because the nature of the negative values of diurnal cortisol slope. But definitely need to go back to check the mean values of a diurnal cortisol slope before you interpret the findings. Okay, just go back to the centering, because as I said, it might be something you might be interested in or you already have done in your studies. There's two common centering approach. One is the group mean centering, which means that you center the variables at the group level by subtracting the group mean from the individual score within like each group. And in this specific could be to subtract the variables at the day level mean from the individual score within each participant. And so for the group mean centering, it's very helpful because the group mean centering can help to distinguish the impact from the within group and the between group effect. So if you are interested in a variable that you measure at the that can be operate at both individual like within person level and also between person level, then you might be interested into using group mean centering. Another that more straightforward, and this is like kind of the syntax in the and plus, if I'm interested in about the centering using group mean centering, and here it's like more group mean. You tell them like a group mean at the personal level to center the age. It's just an example. And by the way, the exclamation in M plus, which means trying to tell M plus don't read this syntax. So if you want this syntax to work, just simply remove the exclamation in front of this syntax. And for the grand mean, it's just pretty straightforward by just subtracting the individual score from the whole sample mean to do that. Sometimes that you might consider using group mean centering because it can facilitate the interpretation of the intercepts. But I want to say the group mean centering and the grand mean centering, I normally don't see they will change the significance of the results, but it does change how you interpret the interception, the intercept from the multi-level modeling, because with the centering that the intercept from multi-level modeling represents the predicted value of the dependent variable, like when all the predictors set to 0. So here is the a more article if you're interested in to learn more about centering. I'm attaching here. I also kind of see we'll almost run out of time, so I have one more slide. Just two more slides to just give you more information if I'm interested into focusing on other diurnal cortisol parameters, such as you are interested in total cortisol output. This is one article that provide a formula that can help to calculate the total cortisol output to do any further analysis. There are also some studies suggesting to not, because most of studies are interested in looking at individual level diurnal cortisol pattern associated with any potential predictors. But for there's article and there are also some more studies trying to understand whether there are any variations across days within participant might have an impact on potential health outcomes. So that's something called intra-individual variations in diurnal cortisol. And here is also additional information that I highly recommend this paper because provide hands-on syntax and also explanations and approaches how to calculate different parameters for the intra-individual variations. And also there are some additional consideration for the softwares, like if you're using the HLM, also you can use R to run the analysis using the LME4 package. And I found that the online resources, which is open, public available, that provide all the syntax. If I'm interested in run the multi-level modeling using R Studio or R. And you also can use the SPSS, SAS, or Stata to run this analysis, and they all normally referred to as mixed effects modeling, but they're kind of the same. As I said, just substitute the equations back to the level 1 model as I introduced earlier. So that's pretty much for what I have. I'm kind of feel I'm go over the time. I'm not sure whether I still have time to answer any questions that you may have. But I want to thank you all for having me today.
Oh, thank you so much. We appreciate it. Yeah, so we are a little bit over time, but if anyone has any questions, this recording does go out to everyone. So if you have to go, I completely understand. If you want to leave your question in the chat, Doctor, if you have time to answer those, we'll go ahead and answer them, and then you'll be able to skip ahead in the recording to get your question answered. But Juan, there is a question in the chat from Juan, and Juan, do you want to read your question, or do you just want me to read it out loud?
Yeah, I'm happy to ask it. I'm happy to ask it. And the M plus syntax, I noticed that you modeled the effect of TSA squared on cortisol as fixed. And I was just curious on how common that is, or if it's expected that we model it as random.
So I think it really depends. So I think when I run modeling, I was trying to that's the two things I will consider. First is that whether the sample size is large enough, because when the model gets complicated, I feel like that's need for more sample size to get more robust findings. So if I have more relatively small sample size, I sometimes would say I will treat as a fixed effect. Just trying to make the models more parsimonious. I think that's one paper talking about whether there's a need to really using like a multi-level modeling. But again, back to your question about whether TSA square should be fixed or random, I would say it depends on your research question, whether there are any predictions that you think might have an impact on the TSA squares effect. And although you're interested in this, like looking at their curvilinear effect, if this is something you're interested in, I would say it seems there's a need to add that as a random effect. Another way, if you feel like I'm not quite sure and I don't know how to make decisions whether I should treat as fixed effect or random effect, I probably would go first to run unconditioned model and treat it as a random effect and see whether there's a significant variances at the individual level or day level. If there's no significant variances at the day level or individual level, I probably will just go back to fixed as a fixed effect.
Got it. Thank you.
Yep, and Juan, we do the same thing in HLM models. So usually what we will do if we don't have a specific hypothesis is we test it. And if there is variability and we have the end to do it, we make sure that we leave it to vary. But if there's not a significant difference, depending on what we're looking for, we just go ahead and fix it. But again, as Dr. said, we test that, and then it all depends on what your question is as well.
Got it. Thank you.
Okay. Are there any other questions? No? Thank you. Oh, Tico, actually, you did have a question. And so I don't know if I answered this correctly, Tico, but there was a question on what S stands for in M+. And correct me if I'm wrong, I think that S just is a marker for a latent variable, but I could be wrong because it's been forever since I worked at M+.
Could you say that again? Sorry, I missed it.
What does the S stand for in M+ models?
Okay, yeah. So it's actually, you can give that any like you can give just any symbols you like. No, sorry, any characters you like, because
sorry, the question was it was asking what S1 was reflecting, and I feel bad because I think I just missed something when you were explaining it. So I understand that it's just like a variable name, but like, so what is it actually reflecting in the output?
I see. Yes. So in the example I provided, so I didn't give like a lot of context in terms of like particular explanation about the M+. So for the, like when you see the regression, right? When I have like the cortisol on, for example, cortisol on TSA, and that's like a slash with a symbol from it. It's basically trying to tell M+ to run the random slope for the diurnal cortisol slope. Because go back to the equation, right? When the parameters estimated for that coefficient, it's when TSA is added as a predictor, the coefficient represents the diurnal cortisol slope. But when CAR is included, CAR included to predict the size of the CAR. So that like S1 in like I included in the example I provided, it's basically to predict the size of CAR. So it's trying to monitor the CAR in the model.
Oh, I was muted. We have another question that says, do you have any resources for constructing results tables and papers? I tend to see coefficients for variables at each level. For example, court day, person, but in my output, I only tend to see the coefficients at the relevant level. So only at person level. And this is from Catherine. And Catherine, feel more than free to unmute and ask your question if you would like to.
I think you summarized it pretty well. Basically, I've just been struggling with this table for a while and trying to figure out where to find the information I need. And I know that's a pretty technical question, so if this isn't the place for it, let me know. But I was just wondering if you had any resources you could point me to, or any, like, just if I'm looking in the wrong place in my results.
Can I ask a clarify question when you're asking the like coefficients for variables at each level? I'm just curious, like I thought the M+ will provide very standard output. If you just put on like which type of output you want M+ to provide. Well, if you have any variables at each level, it is supposed to give you all those coefficients. Are you talking about how to kind of present present the results in a table for publication purpose?
Yes, exactly.
Okay. So I would say for M+, the tricky part M+ is that it's really like not can generate any tables that can just copy paste to a table like that for publication. I would say for trick part, I personally like to copy paste in Excel. And I use the Excel sheet to extracting the results that I wanted to generate the table. I personally don't find any resources that I can go to, but if you want to learn more about like how I do that, I using Excel spreadsheet, I can show that to do, to do how to do it. But I yeah, but I probably will say, yeah, I think someone approach out like R. I think that yes, using R will be more straightforward because it's more flexible in terms of how to save the output.
And yeah, just piggybacking off of that, if you find the answer, I would love to know. But I've been doing the same thing. What I tend to do is I'll copy and paste it into Excel. And what makes it really, really helpful to get it into APA format is to turn off your grid lines. So when you turn off your grid lines, you can kind of see the way that it's going to be formatted without all the lines involved. So if you're in Excel, turn them off. And JASP, which is a GUI for R, also has a couple of really cool packages that will make for less editing. You still have to do a little bit of editing, but they tend to put out some pretty decent APA standard figures.
Thank you for sharing. I didn't know that because I was really kind of like not like actually 100% manually do that, but I do like just copy paste and writing some functions to extracting all the results. And I thought it's really time consuming.
Very. Does anyone else have any questions? And if it's okay with you, doctor, because I know at least with my talk, sometimes people get nervous and they don't want to ask questions. But is it okay for folks to send you an email if they have any questions about your talk, or would you rather not? Would you rather them send them to me?
Oh, of course, just they can feel free to reach out to me if they have additional questions. And also I still have some time, so if you have any questions for me, I can stay here a little longer. But if not, yeah, or you have any other questions later, just feel free to send me email. I'm happy to answer if I can.
Thank you so much. And ditto, if there's anything that I can answer, feel free to CC me. And if anyone was confused and wants access to the other talks, just send me an email. I'll let you know how you can go about doing that, because I know some people have had interest in seeing Emma's talk from the meeting. But other than that, if no one has any other questions, I'll go ahead and stop the recording so we can get that rendered and sent out to everyone. And if you have any other further questions, feel free to email us or stay on after. But I'm going to go ahead and get the recording stopped for now.